Okay, just going through this here quickly for you guys. Dividing polynomials. Okay, we're not going to do the long division. We're going to work with synthetic division and just briefly talk about the remainder theorem. So here we go with this. Sorry about this. I got a couple slides that are blacked out. So the remainder, if the remainder is equal to 0, then it's a factor. So like if I take 42 divided by 6, that tells me 7 is a factor of that, because when I subtract these two, I end up with a remainder of 0. So anytime I end up with a remainder of 0, it's actually a factor. So we're going to use that. So that tells me that the divisor is and the quotient are factors. So on this one, so here's how I'm going to use long division. What I want to do is a problem like this. Maybe this is one that I don't really want to factor, but I think that x minus 7 is a factor. So I set x minus 7 equals 0, and I solve for x. So that's 7. 7 goes on the outside. Now, the coefficients for each one of each layer, so it goes x squared in this case, x, and then a constant. So this is going to be 3, negative 29, 56. All right, I like to put a times sign here and an add sign there. It helps me to remember. Now, this 3 drops straight down. Now, if it's below the line, I multiply. That's why I put the times sign there. So if I wanted to extend this line, I sure could. So if it's below the line, I multiply. So 7 times 3 is 21. Above the line, I add. Negative 29 plus 21 is 8. Now I multiply because it's below the line. Oh, sorry, that's negative 8. So I get negative 56. So now, because this remainder is equal to 0, that tells me that x minus 7 is a factor. And then here's what I do. This is the remainder. This is the constant. This is the x. So that means that 3x minus 8 is the factor. So if I was thinking about this, if I wanted to factor this, it factors as x minus 7, 3x minus 8. That's how it would factor. Now, that may or may not be one that I can do very quickly and easily, but this is just to show you synthetic division. All right, so now this one. This is an example of when I want to choose to use synthetic division. In this case, our choices are, we want to use factor by grouping, 4 terms. But if I look at this back half, there's nothing good about those two numbers. The 23 and the 15, that's never going to work. So I can't factor this. Okay, so now what I'm going to do, instead of doing that, is I'm going to go through and now I'm going to use my long division, my skills here, just like I'm showing you my skills on this. Where's that select? Selectors. Not finding it. Let me do this again. There it is. Okay, so I'm going to take and divide this by x minus 5. So I'm going to check to see if this works. Okay, so x plus 5, so on the outside it's the opposite of it. Okay, now this one starts at x to the third, goes to x squared, goes to x, goes to the constant. 9, 23, 15. There's my line, times, plus, drop it down. 1 comes down. Multiply, negative 5. Add, 4. Multiply, negative 20. Add, 3. Multiply, negative 15. Add, 0. So x plus 5 is a factor. And what I need to multiply x by 5 by to get this is, let's see, a remainder constant x squared. So this is x squared plus 4x plus 3 times this will equal that. So there I factored that. Now what we're going for and what we'll end up doing is we'll look at this last thing because it has a squared. Anytime I get it to a squared, that's where I really want it. That makes it so I can do this problem. I can find out where it all crosses. Because in this problem, remember, I'm looking for 3. And if I was graphing this, okay, it starts down here, ends up here because it's odd and positive. Now, I know one of them intersects at -5. And I want to find the other two chances. So what I would do is I try to factor this. Now that I got it to x squared, I always think two sets of parentheses. What multiplies make 3 adds up to make 4. Well, 3 and 1. So that means there's 1, there's 1, and there's 1. So -3, -1. There's my graph. That's where this is all going. It's all coming together now. Sorry, a whole bunch of them here. Okay, do the same thing here. Now, I'll just go through and give you some examples of synthetic division here from here on out. So 6 goes on the outside. Okay, x squared, x constant. So 3, 20, -12. Times, add, drop her down. 18. Oh, bad, 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 bad. Add, 38. Multiply. 48. So this ends up to be 216. So remainder constant x, 3x plus 38, remainder 216. Ugly one, ugly, ugly, ugly. Okay, now synthetic division has some limitations. It has to be a factor like this. It has to be a linear factor. All right, can't be x squared, can't be x to the third. It's got to be one of these. And honestly, this doesn't work all that well, but the others do. All right, so now -3 outside. Okay, x to the third, x squared, x constant. 1, 5, 11, 15. Times plus. Fall it down. Okay, multiply, add. There we go. Remainder constant x, x squared. There you go. So now I found out that that's a factor. That's all it's asking me to do. Okay, same problem. Same type of thing. Same direction side, excuse me. X to the third, x squared, x constant. Okay, times plus. Fall down, multiply, add, multiply, add, multiply, double check to make sure I got my work right. Looks good. So that means that this is a 84. Add these up, 60. Okay, remainder, constant x, x squared. 4x squared plus 9x minus 28 with the remainder of 60. Okay, -2 on the outside, x to the fourth, x to the third, x squared, x constant. 3, negative, no x squared. There's no x squared, gotta have a place holding 0. Times, add, drop her down, multiply, -6, add them up, -7, multiply, 14, add them up, 14, multiply, -28, add them up, -23, multiply, -46, add them up, -47. Remainder, constant, x, x squared, x to the third. Okay, there we go. Tough one. Now, what happens if I use, okay, now this is using the remainder thing. So now, if I'm told that x equals 2, okay, well, now what I want to do is I want to evaluate this. So instead of putting a 2 in for each one of these, and finding out what that equals, I can use synthetic division to do this too. 2 on the outside, coefficients, so x to the third, x squared, constant, 2, 5, 7, times add, drop it down, 2, 4, 9, 18, 17, 34, 41. So P of 2 is equal to 41. It's using the remainder theorem. Okay. All right, now this just asks me to do long division. What this is trying to show me is what happens when I don't have something. So x to the third, x squared, okay, so this is 1. I don't have an x squared, I don't have an x, but I have a 27. Plus, times, same thing, 1, negative 3, negative 3, 9, 9, negative 27, 0. No remainder there. Ends up working out that way. Oh, okay, now this one, I'm asked to evaluate this. Use the remainder theorem. 1/2, I got x to the fourth, x to the third, x squared, x, and constant. 2, none, 3, and 5. Times add. Multiply, half of 4 is 2. Add these up. I get 4. Half that is 2. Add these up, I get 2. Half that is 1. Add these up, I get 4. Half that is 2. Add these up, I get 7. So P of a half is 7. Okay. That looks like that's about it. That is synthetic division.